Great. I think you can see the presentation.
Yes.
Great. So thanks a lot for the presentation, and I will try to align the talk with the previous presenter. In fact, it's very interesting to talk about the circularity aspect. In any case, it's coming more difficult with regulation layers because we have the circularity, we have the energy efficiency, and we have the resilience. So in that context, I'm going to present the work of today, and the focus of my presentation is mainly on future-proofing environmental energy performance directive. The EPBD is standing for Energy Performance of Buildings Directive. This is the guiding framework that we are following in Europe. We have in Europe so far 27 member states, and they have to use all methodology to model buildings and estimate the energy efficiency and to define thresholds for performance. And in this context, I will link what we are trying to do regarding the energy performance of buildings directive with resilience. So before starting, I want to acknowledge a large team behind this work. It's not a single work, and I want to say the International Energy Agency Annex 80. It was a team of collaborators and researchers, and for sure I want to thank Matt Young also for inviting me to this annual symposium on building energy growth. So this is a work that is full of collaboration and a large teamwork. Now, when we talk about anti-hazard resilience, we need to be more specific and we need to get more information about the type of hazards, because whether it's a drought, a flood, a heat wave, fire, blackout, there are more than 15 different hazards that are defined under the resilience curve category within the international United Nations framework. And the United Nations already developed a framework about resilience where they are defining the different shocks and the different hazards. So this is very interesting to follow as a document. And in general, modern energy codes, they can enhance not only the energy efficiency, but also the building and occupant resilience from passive survivability to climate adaptation. So this is important to keep in mind. Now, when we talk about the definition of resilience, we need to take into account that resilience is associated with shocks. And shocks means that we must have a failure. We cannot claim that a building has a resilient feature without that the building is subjected to a shock or to a failure. And here we can see, I don't know if it's shown in the graph, I will try to get my pointer in red, that building performance normally is stable around climate conditions and design conditions. We have, for example, comfort in this case, we will have a certain threshold for performance. And then we can have some foreseeable extreme weather events without exceeding the minimum thermal conditions of comfort until we have a major event or a major shock that will lead to a failure. And as you can see, failure means that we are exceeding the critical thermal conditions or the critical performance conditions, and we have a kind of stoppage that stops the performance stops until the building or the system recovers and goes back either to the critical conditions or the minimum conditions or the design conditions. So it's very important when we address the term resilience to take this into account and understand that we ask ourselves how long the building will withstand severe consequences of a shock and describe that as resistivity, and how quickly can a building get back to the acceptable conditions, and we call that recovery. And for sure, we need to look also at severity, because today weather files will not indicate the severity of weather, and therefore sometimes we need to create short events like short extensive heat waves or like long extensive heat wave, or we create power outages and use these events to test our scenario in order to see what might happen during the summer, during the winter, whether it's cold spells or heat or power outages or any other shock that will lead to a failure and exceeding the critical conditions. Now, in Europe, a very important phenomena that is happening in the last years that we are moving from overcast skies and intermediate skies towards clear skies and clear turbid skies. And this is a big deal for European climate because, unfortunately, in most modeling scenarios and in most weather files, future weather files, there is an underestimation of solar radiation. And there's many scenarios that the future will bring more humidity and rain, while in reality we are seeing in the last 20 years that it's getting more radiation and we are having a change of the sky. And very few studies are studying the sky. And it's very important because the sky is a very good predictor for what will happen and what type of weather we will have. So Europe is warming very fast, and one of the consequences of this change of the sky makes resilience a very important topic. So we are trying in this context to see what are the conflicting measures that could be contradicting when we are looking at resilience in the existing building codes. And we can see that, first of all, we have a conflict, for example, between the air tightness and ventilation during heat waves, because from one side we close the air or the tightness of the building, on the other side we are trying to benefit from natural ventilation. So this will be definitely one of the contradicting conflicts in relation to the thermal mass and to the shading. Also, another important aspect here is that we are going in Europe to a full electrification. So we will abandon fossil fuel, natural gas, and slowly also we will ban the use of nuclear energy by 2050. And while doing that, we will go in a full electrification, which will make us vulnerable to blackouts. So in this sense, also we have conflicting agenda because from one side we are trying to increase efficiency and make buildings carbon neutral, but on the other side, we are increasing the risk and the stress on the whole electric grid in Europe, which is a very old grid and it is not coherent across the different member states. So this is also a conflicting measure in relation to resilience, and for sure we have a conflicting measure related to acoustics. We have in Europe now more and more urbanly dense cities, and we have less and less option to have single family houses. We are going to archetypes of apartment buildings, and this means that we need to make sure that acoustic and acoustical comfort is well maintained. But on the other side, we try to rely more and more on night cooling and day ventilation during natural ventilation during day. And you can see here the conflicting objectives that are coming. And the more we have the urban heat island effect, the less cooling in general through passive measures or airflow will be more effective. And for sure, the dependency on photovoltaics creates also problem with power outages. It's not a surprise that we find today a lot of neighborhoods, they are cut from the grid because they have overproduction of photovoltaic. So we see here a big complexity that we need a lot of storage capacity, but because of the surge of use of electric photovoltaic panels, it's a good beneficial measure, but on the other side, it fires back on other aspects. So resilience and efficiency are not mutually exclusive, and we need to clarify the design intentions to avoid the clash when multiple hazards are present. Now, when we look at another important aspect, which is the quantification of thermal resilience in buildings, we can see that we have different risks like overheating. We look at thermal autonomy. We want to make sure that the number of hours of certain indoor temperature remain within a comfort limits. And we have also recovery time problems because in this sense, we try to make sure that the building will recover within a certain time limit. Less than 6 hours, then it will be good. More than 12 hours, this will be a poor response. So we are trying to equip our building with this aspect, which is also a challenging aspect. And for sure, we are looking also to the adaptive comfort and the duration of the measure that will take. How far can we go with adaptive comfort measures? We have the ASHRI already. ASHRI 55 has an adaptive path, while the SEN 16789, the European equivalent of ASHRI, has different thresholds. And we find other standards like the Dutch ISO that has more tolerant adaptive comfort. So today, adaptive comfort is becoming a more and more flexible measure, or having a flexible band, which will be very complementary with the resilience concept, but until where we will accept certain limits of comfort. And for sure, the hydrothermal stress index, which is very important. Europe is a continent with a lot of humidity problem and rain, so those will be also very important quantifiable resilience indicators that need to be integrated, or they are now taking part of some new standards on a national level. So the key performance indicators can inform the life cycle impact assessment overall by weighting the resilience indicators, for example, indoor overheating or recovery time, based on event probability and duration. We can bring these KPIs or key performance indicators in the European or the Energy Performance Directive in Europe. Now, we should be realistic and we should see what's happening on the terrain. In reality, today in Europe, there is a lot of implementation barriers, and we can see that there is a lack of harmonization. Europe needs resilient metrics that also can guide the renovation wave, because actually we are renovating buildings by adding a lot of insulation, airtight, making the building airtight, tight. And on the other side, we are facing warming, global warming, and a planet that is getting warmer and warmer. So we can see a very clear misalignment between the public perception and the climate reality. And the energy performance of building directives legal mandate is very energy centric. And when the European Commission tried to look more in the future, they transformed it from an energy centric to a carbon or greenhouse gas emission centric mandate. But this is not sufficient, because resilience is more beyond that. Resilience more is about catastrophes, hazards, shocks, disruptions, which means that while we are trying to reduce the greenhouse gas emissions and counter the global warming phenomena, we need also to live with these hazards. And still, the legal mandate for standards still are not sensitive to that. So we have a lack of harmonized link between resilience, key performance indicators, and life cycle impact assessment overall indicators. And you can see the previous presentation of Mr. Colker when he was talking about circularity. Well, circularity is strongly embedded in the life cycle impact assessment paradigm. So you can see that they are intersecting, and they will become on the agenda, top agenda in the next years. And for sure, something that many people forget about is that we have a very, very present policy saturation and fatigue, because we have started our regulation in 2006, which was very strict, and every 5 years we update these regulations. We started with energy efficiency, nearly zero energy building. We went to zero energy. Now we are looking for carbon zero energy building and positive or plus energy building. And now we switch from energy to carbon. And while we are switching from carbon, the paradigm of circularity is pushing. And in the background music, we have the resilience paradigm. So this is all making a lot of necessity to update and to change and continuous modification. As a result, we have strongly bureaucratic administrations that are unable to follow the pace, resulting that we have a policy saturation and policy fatigue, and the overall stakeholders, they find it difficult, especially that we have a big divide in the society. We have businesses and private sector that is eyes on the ball and catching up and moving forward to the future, while the majority of public administrations and the citizens in the middle class or social class, they are unable to follow this change. So we can see clearly these are the problems, and for sure also the research and policy gap. Research is way advanced than policy, because policy is based on consensus. So we have still a lot of things to implement to cross these barriers for implementing resilience metrics within the energy efficiency policy. So the energy performance of building directive should evolve from the efficiency based to a performance and risk based design, and this will be very important paradigm shift in the next years in Europe. I cannot say that we are there. We are even at the beginning. There is very little awareness about the term resilience and what it means. So I can more talk now positively on the future, and I can share with you what we are trying to work on. Well, we have good examples in Europe, and we have positive, some positive implementations from energy-only compliance to climate-proof performance. For example, Denmark and France, they are standing as one of the few European countries that have a very good building regulation explicitly linking energy efficiency with carbon targets and resilience. And this is very interesting to follow and to um, witness how this is change is happening. What is now also happening, some discussions in the energy performance of building directive in Europe in some of the annexes, especially for the energy performance certification, is to add resilience performance indicators. Maybe we will not see that in 2028, but it's very clear that starting from 2023, in 2030, sorry, 2030, we will have some resilience performance indicators that will be introduced in some national codes. And already it's happening now that we are coupling the life cycle impact assessment or the circularity concept with risk-based design to capture both long-term efficiency and short-term hazard performance so that we can bring mitigation and adaptation in the loop. So these are all good and positive signs. And for sure, it's taking time, but it needs to be pushed in the implementation that we harmonize standards with data and bring more EU protocols to cut the methodological inconsistencies and add certain threshold for thermal release resilience label. In Europe now, we are trying to find a label to say what is a resilient building, and this is more an initiative from the private sector with the rating systems. So from there, we are moving forward to combine a policy governmental approach with a private sector initiative, standardization, or rating system approach so that we also have a definition of what is a resilient building. Because, like in any country, we need always to have examples or prototypes. If you remember how the passive house was a leading example that introduced a lot of change, we need some examples like that, that we first agree on what is a resilient house and have some experiences with some buildings that are implementing and adopting these concepts. So we can't regulate what we are not measuring, and we cannot regulate what we are not building. So there's the door is very open for the next year to have pilot projects in this area. Well, this ends up my presentation of today. I'm available for your questions, and I'm looking forward for the exchange. Thank you for your time, and thank you for the invitation.
Great. Thank you so much, Dr. Attia. Can you hear me? Okay, my mic's been a little funky. Can you hear me?
Yes.
Yeah.
Okay.
We can hear you. All right. So we just have 1 minute. I see a question did come through the chat. So it says, you mentioned several conflicts like air tightness and ventilation, or the risk tied to full electrification. How do you think we can better balance energy efficiency goals with the need for resilience so they actually support each other rather than compete? Good question. I mean, that's so easy to answer.
Yeah. Well, thanks for the question. What we can say is that we have a lack of clarity. What's the building of the future? Is it a high-tech building or a low-tech building? Is it an autonomous building that can survive for certain events or certain duration to be completely passively operating? Or is fully high-tech 24/7 with mechanical ventilation, with systems integrated depending on the grid? So until we figure out this difference of high-tech, low-tech, and how far we can depend on natural resources. For example, cities will be different than rural areas. If I am in a very crowded city and the air is polluted outside, the urban heat island effect is playing a major role. I will be baked if I open the window. Then it will be very difficult in this sense to not rely on a fully high-tech building that has a lot of backup system with batteries and internal scenarios of functioning and operating. For example, we had a building, a senior house in Belgium, and the whole scenario was to evacuate the different floors during a heat wave if there is a power outage and assemble all occupants in a very cold place in this building. So here we rely a lot on occupant adaptation and behavior because we cannot open windows in this case because the building is completely operated with BMS or building automation system. While in other situations, when we are in a countryside or a rural area where we can open the windows, we are not afraid of air quality and we can operate, we have a low density, then the passiveness works very strongly. So it's getting now more complex on how even when we teach to our students, when I tell them they have to make benefit from natural ventilation, I think we have today two regimes in the whole world: highly densely populated areas and low density areas. And I prefer to develop guides and recommendations that distinguish those two different realities: New York, Hong Kong, big cities, Chongqing in China, is not like when we are talking about Denver, Colorado, for example. So this will make it also difficult how to make standards that are sensitive to this difference in general.
Thank you, Shady. And I would just add to that, what's great about all your KPIs is that you can at least identify the conflict and then move from there based on all those considerations you shared. Okay, thank you so much.